Class, this is another beautiful example. Remember the one we did before has only one support, and it is a meter rule. And I did say that you can have different lengths. Here, it is no more a meter, but 6.0 meters. Now they said a uniform beam. So it means the weight of that body will be at the center. Now we now said, let's say this is our beam. Now we were told that this is 6.0 meters. 6.0 meters. And weighing 4 kg. Weighing 4 kg. So it means from here to here, which is our midpoint. I put it here. That's 4 kg. 4 kg. 2 Newton now is going to be 40 Newton. That is, you multiply by 10. Remember, in our definition of our moment, we never said mass times distance. We said force times distance. So I have to convert this one to force by multiplying it by 10. Anytime they give you mass in kilogram, you multiply by 10. But if you are giving mass in a lower unit, that is gram, you have to first of all convert it to kilogram before you multiply it by 10. You must not multiply gram by 10. If you do that, that is a foul. It is a foul. You have to what? You have to multiply it. You first of all convert it to kg before multiplying by 10. But thank God, here we have been given in kg. So we just need to multiply by 10. So that is the mass. Class, where is going to act? It's going to act as 3.0 meters. This side too is going to be 3.0 meters. So we are here now. Now, they now said, placed on the support. On support P and Q. Placed left and right. Left and right. Where? 1.0 meter from each end. So it means, I will say, this is my support 1. From here to here is 1.0 that they gave us. Definitely, from here to here is going to be what? It's going to be 2.0 meters. So, this is our, which letter comes first? P. So, this is our P. We go to the next one. They say from here to here is 1.0 meters. Definitely from here to here too is going to be 2.0 meter. Not 20, 2.0 meter. And this one is going to be what? It's going to be our Q. Good. We are moving. So it means place left and right 1 meter, 1.0 meter from each end of the beam. We are done. We go to the next one. They said weight of mass 10 kg and 8 kg are placed near P and Q. Who wants this 10? That is P. So near P, 10 kg. I have my 10 kg. 10 kg, which is same thing as a what? 100 Newton. I multiply it by 10. That is the other one. Then the other one is what? That is 8 kg. 8 kg. This one is same thing as what? 80 Newton. Class, are we there? Respectively, one each end of the what? Of the beam. Fine. The question now says, calculate the reaction at P and Q. Good. I have made the sketch. Class, if you are able to make this sketch, your problem is halfway solved. Let us now see. Now, class, we are having 2 supports. Unlike the one we did the other time, that we have only 1 support. We said we should take our moment about one distance. So, this time around, we want, if you want to know the impact of Q, what the impact of Q is doing to ensure that this thing balances horizontally, it means you have to remove it. When you remove it, what happens? It will come down. You know, before it was like this. When you remove that Q, it will now come this way. So it means you have to, where is the body going to turn? It's going to turn about P. So that's why we now say, taking moment about P. We want to know the reaction of Q. So let's go now. To find solution now. Solution. To find the reaction at P. To find the reaction at P. Therefore, take the moment about point what? Point Q. If you want to find the reaction at P, you take the moment at Q. Is that understood? You take the moment at Q. Indicated. I have shown the first diagram now. The solution. To find moment, to find the reaction at P. That is, I want to know the effect of P. What is the contribution of P towards the stability of this beam? So it means, if I want to know the contribution of P, it means I have to remove that P. It is when you remove the P, that is when you now say, oh, when P was there, this is what he has been doing. So it means, now if I now remove this P, where will the beam turn? Of course, it's going to turn at the other support. So that's why we now say, take moment about point Q, because that is where it's going to turn. So now, let's go to, now the moment I now remove it, it will now look like this. It means I have removed it. Remember, this is my P. Are you there? So now, the moment I remove it, what happens? The beam will now come down. When I remove it, what happens? The beam will now come this way. It will come this way. Where will it turn? It's going to turn about this point. So now, let's go. If I take this one, you take this one. This one will have to come this way. And of course, our force, the reaction of P, it has to counter. This one, they are going this way. They are going this way. These two, they must provide a counter reaction. So now, we go to the, you know, this one is anti-clockwise. So anti-clockwise now. Anti-clockwise moment. What's the first one we have? We have 100. 100. Look at the distance of 100. 100. This 100. What's the distance to this point where the body is going to turn? I have 1 plus 2 plus 2, making 5. So it's now going to be 100 times 5. Plus, because it's not the only one, that is summation of clockwise. It's not the only one going. Let's see the next one. You know this one too is going this way. That is 40. What's the distance to that Q? It's just 2 meters. I will say 40. That is my 40 times what? Times 2. Do you have any other anti-clockwise? No, we do not have. Because these are the only two that will go. Now, this one will now give me 500 plus 80. And the total of anti-clockwise, that is going to be 580 Newton meter. Newton meter. So let's go to our clockwise. Our clockwise now. Now, when these two forces, two weights, the weight, when they are going this way, this one they have to produce a counter. So this one, the distance is going to be from here to this point where you are taking your moment. So it's now going to be 4p, that is 2 plus 2, that is 4, times this p, that's 4p, plus this man goes this way, that is 80 times 1. So this one will now give me 4p plus 80. From the principle of moment, summation of clockwise moment must be equal to summation of anti-clockwise moment. What's my clockwise moment? That is 4p plus 80 is equal to, what is my anti-clockwise moment? That is 580. When you collect the like terms, 4p is equal to 580 minus 80. That's 4p is equal to 500. Then we now have p is equal to 500 divided by 4. We have p is equal to 4 in 5, 1. It remains 1. In this one, in 10, that is 2. It remains what? It remains 2. In 20, that is 5. So the effect of P is equal to 125 newtons. Is that understood? I have found the reaction at P. Let's get that of Q. It means I have to remove the support Q. I remove the support Q. So here I'm going to have Q now. Now, where am I going to take my moment? I take my moment to find the reaction. To find the reaction at Q. Therefore, take moment about point Q, about point P. Summation of moment about P is equal to 0. Alright, let's go. Summation of moment about P is equal to 0. So yeah, let's go now. This one will now come this way. That is Q 2 plus 2. That is from here to here. That is, let's see, our clockwise. You know the moment I remove this, what happened to it? It means this one will go this way. I change the direction now. This one will go this way. This one too will go this way. What's our clockwise? Yes. I said you take moment about point P if you want to find the reaction at Q. So anywhere you are taking moment, summation of moment about that point is equal to 0. So now we go. You know, the moment I remove the support here, my plank is going to swing this way. That is, it will go this way. It will go this way. Now it means our clockwise. Let us now see this 80. This 80 Newton, what is the distance from where it is hung to where the body is turning? We have 1 here, we have 2 here, we have 2 here. So it's going to be 5. So it's now going to be our clockwise moment here. We now have 80 times 5. That is 1 plus 2 plus 2. That is 5. Then this one too is going the same way. 40 times 2. That is plus 40 times 2. Class, do we still have any other clockwise? No, we don't have any other clockwise. So this one will give me, that is 400 plus 80. So, and that is 480. That is 480 Newton meter. That is our moment there. Now, let us now get the other one. So, this one will now move this way to counter. This one will move this way, and this one too will move this way. I mean our Q. So our Q now, that's anti-clockwise. Summation of anti-clockwise moment. What's our anti-clockwise there? Q times what's the distance? 2 plus 2. That is 4Q. 4Q plus, you know this one has gone this way, and this one too is going the same direction. That is 100 times 1. That is 100 times 1. So here we now have 4Q plus 100. And let's go, class. From the principle of moment, summation of clockwise must be equal to anti-clockwise. So we now have, okay, So this one is now going to be 4q plus 100. That is our, what is that? That is our anti-clockwise. Now from the principle of moment, summation of clockwise moment must be equal to summation of anti-clockwise moment if that body is in equilibrium. What is our clockwise moment? That is 480 is equal to 4q plus 100. If this 100 goes here, we now have 480 minus 100 is equal to 4q. So this one is give us 380 is equal to 4q. We are looking for q. So 4q is equal to 380. Q now is going to be 380 divided by 4, which is equal to, that is 95 Newton class. That is 95 Newton. So it means this man is providing 95 Newton. That is our Q. Our Q here is 95. Class, there is a way by which we check if we are right. You know, another principle of moments says the algebraic sum of all vertical forces must be equal to 0. That is, downward forces must be equal to upward forces. Let us now see whether we are right. Downward forces must be equal to upward forces. What are our downward forces? Our downward now. Downward forces must be equal to what? Upward forces. What are our downward forces? We have 100 plus 40 plus 80. That is 100 plus 40 plus 80 must be equal to our upward. That's 125 plus 95. Class, this plus this gives us 220 is equal to, if I add this to this, we have 0. This one is 2. So you can now see that we are very correct. Class, if you enjoy this topic, do subscribe to my channel and like the video. Thank you.